Hi guys, welcome back to another episode of Welding with Mr. Sapanic. Today's lesson is going to be talking about different joint designs and welding terms. Let's get right into this. A couple of things we're going to do is identify common welding terms. We're going to describe some common types of weld joints, describe common types of welds, and then the basic weld design considerations. A weld pass is a single progression of a weld along a weld joint. So you have single pass, you have multi-pass. Now with these passes, the single pass, the first pass of your weld is called your root pass. Okay. The second pass that goes over top of that, now depending on what the joint is, can either be considered what's called a hot pass or can be considered an intermediate pass. Okay, which both are very similar as far as terminology goes. Hot pass is usually considered a hot pass when it's done, like say on an open root V groove, to where you need to like have a little bit of root reinforcement, a little bit more penetration, so that hot pass will actually take that root pass and push it through the joint a little bit farther. Now, hot pass in a fillet weld isn't necessarily going to do that, so that would be considered an intermediate pass. A crater is a depression, a determination of weld bead. Now, craters usually always happen, especially if you're welding on thinner material, because you're burning up that base material and you are not putting filler metal in there. Usually it happens at the end of your weld. Now, a couple of ways to help with these craters. The first thing, when you get about, let's say, 1/2 of an inch before the end of your weld, 1/2 of an inch to an inch, you can actually take that weld and start to feather it off a little bit. So you can go a little bit faster to have a little bit of less penetration into the end of your weld. That'll make a little bit of a smaller crater. Another thing you can do is when you get to the end of your weld, say if you're running on a 10 or 15 degree travel angle, you can actually take that travel angle and you can drop it to like 45 or 50 degrees. So instead of your rod melting into the base material, your rod is now melting just the weld itself sitting on top of the base material. So there's just a couple of ways that you can actually prevent, well, not prevent, but lessen the crater, because the crater is always going to happen, especially in stick welding, but you can lessen the crater by doing those couple of things. Weld reinforcement is the amount of weld metal in excess of that required to fill a joint. So looking at the picture, we have our entire weld here, okay? The reinforcement can either be on your face or it can be on your root. Now, if it is on the face, which is the top of the weld, that is called your face reinforcement. The root down here is everything penetrating through root pass, which is called your root reinforcement. The weld toe is the junction of the base metal and the weld face. Okay, your weld toe is typically here and here. Now, don't get the weld toes confused with the weld leg. Weld leg is the distance from your vertical piece to the toe of your weld here, and then your weld leg is also from this horizontal piece to the toe up here. So your weld leg is here and here. Your weld toe is what actually touches the material on each side. This is typically where you get undercut on the toes of your weld because of having maybe a different or a wrong rod angle or running too hot on your root pass. So those are going to be your weld toes. Then your weld face, like I tell all of my students, the weld face is what everybody sees. You're at an amusement park and you're walking up a set of steps and you look down at the steps and see them welded together, you're looking at the weld face. So that everybody sees. Welders should be familiar with how loads impact welded joints and with the criteria for selecting the proper joint configuration. Now we're going to go to this displacement here. We're going to focus a little bit more time on the displacement. If we have our load in the center here, and let's say, for example, this is 2 inches wide, okay? we're going to have all of our pressure on a 2-inch wide piece. Chances are we're probably going to bend that. Now if we go over here and say this is 6 inches wide, so now instead of our surface area covering 2 inches, we're now covering 6 inches here, and we're going to have more load displacement, so that means we're going to have less chance of this actually bending here. There are 5 basic weld joints used. They are the butt joint, T-joint, lap joint, corner joint, and edge joint. And we're going to go over those here in just a second. A butt joint is a weld in which 2 members are set approximately level to each other and are positioned edge to edge. Now, the only time that they're not going to be necessarily level with each other is if you are welding with different thickness butt joints. Let's say let's take this square groove here. Okay, let's say this one here is 1/8 of an inch, and this one here is 3/16 of an inch. So chances are these are not going to be parallel across here. One is actually a little bit thicker. Okay. We have single groove, we have single J, we have single V groove, we have single U, and then we have double. The only time you guys are going to use any of these doubles is if you are welding on thicker material. If we're welding on anything that is 3/16 of an inch or less in thickness, you're going to see a square groove here. Okay, there is no edge preparation required. You're going to see just like this. Now, if it's 1/4 of an inch or thicker, you're going to want to do some preparation here. Okay, so we can do a bevel, we can do a J, a V, or a U. Now, over here on this side, we're going to say 1 inch thick. If you have material that's 1 inch thick or thicker, you might want to think about running a double bevel on that, or a double J, or a double V, or a double U groove. Now, if it is preparation for a certification test, we're going to be sitting over here with the single V groove. If it is a preparation of thin material, maybe thinner material, we might do a single U groove after it's already tack welded together to ensure that we're going to get 100% penetration. A T-joint is a weld formed when 2 members are positioned approximately 90 degrees to one another in the form of a T. Now in the class, these might be known as T-joints, X-blocks, fillet welds, whatever you want to call them. Same thing here. We have our square, which there's no joint preparation at all. We have a single bevel here, single J, double bevel. Now, once again, any of the doubles, usually it's going to be on real thick material. If this was 1 inch thick material here and here, and if I just made a weld here and a weld here, I'm going to have like 3/4 of an inch worth of material here that's not even welded. Okay, so in that circumstance, I would probably want to put maybe a double bevel or a double J on there. That way I can ensure, instead of having 1/4 of an inch overall penetration, I could have maybe 3/4 or 7/8 of an inch overall penetration into that base material. A lap joint is a weld joint between 2 overlapping members in parallel planes. Okay, this is also, it's a lap joint, but this is also a fillet weld. Okay, take a look at the angle, and the way that this is sitting right here, this is actually a horizontal fillet weld. Now you can have one weld on the top and then also on the bottom. So you can have a single fillet weld, or you can have double fillet weld. Really depends on what it is that you're doing. If you are having something where their load is going to be pushing down right here in the center, you're going to want welds on both sides. If you're having something to where a load is only pushing on against this weld, then you're not going to need welds on both sides. But that's going to go with the welding procedure too. A corner joint is a joint formed when 2 members are positioned at an approximate right angle in an L shape. This is very similar. This is actually a fillet weld here as well. All of these are fillet welds. Now you have 3 different ways to make corner joints. You can make a flush corner joint, a half open corner joint, or a full open corner joint. Now when you make a flush corner joint, if I made this piece and this piece both, say 2 inches wide, from here to here is going to be 2 inches. and then from here to here is going to be 2 and let's say a quarter if we're using 1/4 of an inch material. If you make a flush corner weld, you have to make sure that you account for the thickness of the material if you're going to be welding this flush like this. I don't recommend this per se because you're getting a weld here and then a weld here with no joint preparation. You have a lot of weld that is going to be not penetrating in any. If anything, I would overlap it slightly like this, a half open or even a full open joint. This will ensure that you get 100% penetration. This is going to give you 90 or so, without joint preparation, 90 or so percent penetration. An edge joint is a weld joint formed when the edges of 2 or more parallel or nearly parallel members are joined. Now, an example of an edge joint would be, let's say you have to make a piece of material that is a 1/2 of an inch thick. You don't have any 1/2 inch thick material, so you need to take 2 1/4 inch pieces, butt them up to each other, face to face, and then you have to perform a weld all around the edges of that. Now, if it's a square edge, remember anything 3/16 or less does not require a bevel. So a square edge, if it's 3/16 of an inch, you'd be okay to make a weld around the edge of that. If it's more than 3/16, I would put bevels, a double bevel on that actually, especially if it's the same thickness material. Now, 3/16 you'll necessarily have to, but I always recommend that you get a bevel on your edge joints just so you know that you're going to get adequate penetration. Now, if this is a bigger piece of material, we might go in and take one of those materials and cut some holes in them and make either some slot welds or plug welds to support the center of those and then grind them down smooth. Weld type is a cross-sectional shape of the weld. So these are all of our welding symbols. So if we have a square groove that's just butted up to each other, we have our V groove where we have equal V's on both sides. Our J grooves, our plugs welds, slot welds. So these are just all different types of welds and joints here. We have 4 basic positions, and those will include flat, horizontal, vertical, and overhead. Now, I always like to tell my students just because it's above your head does not mean that it's overhead. You have to look at where the rod angle is pointing to. Correct groove angle is required for good bead penetration and shape. So if you're welding a V groove, you want to have between a 45 and 60 degree overall groove angle. Now, once again, that's going to depend on the thickness of the material, that's going to depend on the welding procedure, and that's going to depend on whether or not it's going to be an open route or if it's going to be with a backing strip. Now, chances are, if it's an open route, you want to have about a 60 or so degree angle. So that's about a 30-degree bevel on each side. If you're welding with a backup bar, you're going to have a wider opening there at your root. So you're going to have about a 1/4 of an inch opening rather than an 1/8 of an inch opening. So you could correct that a little bit and have a 45-degree angle. Now, the downfall of having a larger angle is if you have something that you're working on that's time sensitive, the bigger the angle, the more weld you're going to have to put in, the longer it's going to take you to get it done. The smaller the angle, the less weld you're going to have to put in, but the more chance that you have of having undercut on each side of your weld. Large groove angle should be used in pipe welding to ensure complete penetration. So back to that 30 or so degree angle. We usually recommend about a 60-degree angle when you guys are prepping for pipe welding. The bigger the pipe, the more welding you have. So if you're working on a 75-degree angle, a 10 or 12 hour weld with a 60-degree overall angle is now going to be a 14 or 16 hour weld with a 75-degree angle. Overly large groove angle wastes filler metal, time, resulting in greater welding costs. Sufficient root opening is needed for full penetration. Remember, 3/16 or less does not necessarily have to be beveled. If it's greater than 3/16, you want to have a bevel on there. And the bigger the gap you put on here, the harder it's going to be for your weld to stay in here, especially if you're running real hot on your weld. So I say 3/32 to 1/8 of an inch gap for beginner welders. 1/16 gap up here is going to be for those real experienced welders that like to run real hot and fast. The 3/16 gap is going to be for those welders who like to run cold and slow. Proper root face must be provided for a quality weld unless a backing strip is used. So if you have an open root, which is what these look like here, you want to have what's called a landing. So that's a flat spot at the end of your angle. Usually it's about 3/32 to 1/8 of an inch for open root. If you are running not an open root with a backing strip, you do not need to put a landing on your material. That is just going to be straight down to a point. Okay, the backing strip is what's going to take in all of that heat. Proper fit up ensures that joint members are in correct alignment. They have the correct edge preparation and have the required root opening for proper penetration and sufficient weld reinforcement. If you're dealing with something that is like a bridge, you want to make sure that you have sufficient weld reinforcement because it's taking a lot of pressure, a lot of weight, a lot of people driving across that. You want to make sure that you have a good solid weld. A couple of things to remember. The root pass is the initial weld pass, okay, with complete or partial penetration into the root of the joint. Remember, the more penetration you get, the better off you're going to be. Square groove butt joints are typically used with materials 3/16 or less. If it's 1/4 inch thick or more, put a bevel on it. Double V groove is suitable for all load conditions. T-joints formed when the members are positioned at 90 degrees to one another. A lap joint's usually welded on both sides, but can be welded on one side depending on what you're doing. Groove weld should use the smallest root opening and groove angle possible to produce a sound weld with the least amount of filler metal. Remember, if you're doing something that requires a time-sensitive type of weld, the smaller the angle, the faster it's going to get done. A plug weld or a slot weld is used to join overlapping pieces of metal. So just like I explained a few minutes ago, you would have 2 1/4 inch pieces, you need to make a 1/2 inch piece, you slap them together, you weld around the edges, and then you have a hole in one of those 1/4 inch pieces of material, and then you do a plug weld, or you can have a slot in them as well. AWS codes and other applicable codes, which would be API 1104 or ASME Section 9 for pressure vessels. They provide guidelines and specifications for designing quality weld joints. And joint preparation guidelines must be followed closely to provide good fit-up during welding.